Good morning, or good whatever time it is wherever you are. Here now, it is 8:30 on a Tuesday morning, and today I'm going to do something that I think is going to be really pretty cool. We're going to do some brain rewiring in real time, and I'm also going to talk about some things related to AI and code revisions. And obviously, the parallels are going to be clear. For those of you who followed me for a long time, you're going to go, "Ooh, good one." All right, let me go fix my links here. All right. Have some old programs you'd like to revise. Oops. Ask the hypnotist. Nope, not asked. Suggested the hypnotist. Suggested the hypnotist with a wink. Now, smile. There it is. Pretty good. All right. All right. This one's going to be a really good one. I'll give people a couple of minutes to jump in on this one, but it's going to be really good. All right. Let me do one more check on something here. All right. Yeah, we're good. Okay. So let's get started. Welcome to Daily Upgrade with Jason Andrews. My name is Jason Andrews, and I'm a hypnotist, which means I can change things on the inside, which is great because today I'm going to be talking about AI and revisiting old code, fixing old programming code. And because I am a hypnotist, I'm going to be doing some things to change things on the inside of your head while you watch and listen. All right. So it's going to be great. And the first thing we're going to do is we are going to take a deep breath in, hold it for a moment just to get some tension going, and then we're going to let it all go. All right, ready? Breathe in. Hold it. And let everything go. Good. And if your mind has been anywhere, all over the place, or anywhere else up to this point today, we're just going to take all that and bring it into here so you can focus in. Now, as I said, today is going to be about revisiting old code. Now, I'm going to tell you a story, and this is going to do some work changing things on the inside for you. So when I was a kid, this is a long time ago, I had this super powerful computer called a Commodore 64. It had like the processor was 8 hertz. I think they're in like, millions of hertz at this point. Maybe even billions of hertz. But this was a powerful computer for the time. 64K memory. It was awesome. And I love that thing. I started doing some programming when I was like 8. We got this computer and I was just, glued to it at the time. I eventually went into doing IT work. So it was a good career for a while. But the thing is, we played this game, right? My brother and I and some of our friends. It was this basketball game, and it was just text based, and it was statistics based, right? So you'd have the roster of all the players, and then you'd have like the how many rebounds they got and their field goal percentage and free throw percentage and all this stuff like that, and then it would simulate this thing where the whoever would have the ball and they would pass, you would say pass or shoot, and they would say what your percentage of shot was, and you would say shoot the ball, and they'd shoot the ball and you'd miss or score, and it was really really realistic. I mean, oh my gosh, the games that it produced were sometimes indistinguishable from the play by play that you would hear on the radio back at the time. I mean, it was so realistic and it was so fun and compelling. And we played hours and hours and hours of that game. Hours and hours of that game. And what's really interesting is now that I've got a subscription to Grok, I was like, you know what? I came across it. Something happened and I came across it. It popped into my head and I thought, you know what? AI can do all this coding stuff. I says, okay, so I asked Grok, I said, hey, can you, if I give you this, really old disk image file, right? You can download all this retro stuff online now. So if I give you this disk image file, can you recreate this in Python? And it was wild. It was wild. It was like, oh yeah, it looked up, this game, and it was like, oh yeah, I know what that game is, Final Four by Lance Hafner or whatever. And okay, here's what you do, and it had helped me download this emulator and get the image file and put it in there, and it was like telling me what code to type into this like ancient looking interface, and so I gave Grok all the code, and I said, okay, give me first of all, tell me what it's doing. Tell me how this works, because when we were playing, we always wondered what was going on under the hood, right? Because the stuff under the hood is where it all matters. That's where the real stuff is happening, and we couldn't see that. We could only see what it presented to us, right? It said, okay, well, this player has the ball on your team, and you can shoot or pass or whatever, and if he tries to shoot, it'll be this percentage shot, and right, so all that stuff. Now, but we didn't know how it figured out the numbers, how it worked it all out. And so the first thing I did is I said, Grok, tell me all the mechanics here. Tell me what's going on. Tell me what's happening. And so Grok was like, sure. And then this is what it does, and then this is what it does. And if you pass, it does this random check to see who's which other player to pass to, and then this is how it determines what your shot percentage is. It takes your player's season field goal percentage, which is usually like I don't know 45 or 50% or whatever, and then it adds a variation of plus minus 7%, and then whatever the other team's matchup is, if they're playing man-to-man defense, then you subtract the defensive skill of the opposing player, right? And then there was this sort of like wow factor called contribution. That if you had a lot of, if your player had a lot of contribution, they would have a much higher chance of getting a really good shot. All this stuff under the hood, we kind of knew what was going on, but we really didn't. And so I was like, wow, that's great. So Grok, give me a Python version of this. And you have to play around with the AIs because they're like, oh, this one's pretty close. And I was like, no, give me the exact one. And so after about 2 or 3 iterations of saying, no, I want it exactly the same, I want it to produce the exact same output, it finally gave me the code, gave me this Python version of the code. And if you looked at the original version, it was written in like BASIC or something like that. And it was this kludgy mess of stuff that was impossible to read. It was not organized. Everything was back then. All the code was written in. You had line numbers for your code. It wasn't just straight down list. You'd have to label each line with a number, and then instead of saying go here or there by name, you would say go to this number. It was so messed up, and there was all this weird symbolism, and the words just weren't really readable or usable. You couldn't tell what was going on. You couldn't tell anything that was happening. Now, the people who wrote it back then were like code geniuses and they could figure it out, but like who else could do it? It was a mess. Now, this Python version, Python is a modern programming language that's user friendly, and oh my gosh, it was so clear. It was so clear. Everything was broken out into processes. This process does this. This process does that. That process does that. And it was broken out into flows, right? First, this team would do this, 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 and this. Oh, and then there's a change of possession because it simulated either a missed shot and a rebound or ball went out of bounds or whatever. Okay, now it's the other team, and they go through this process. And so no matter what was going on, they had a definable process that was very traceable. And you realized that there were certain things you could do by once I looked at the code. I looked at the code because I can program. That was one of the skills that I've developed over the years. And so I looked at the code and I figured out, oh gosh, I think I know a way to improve how I play the game. Because now I know the mechanics underlying everything at the under the hood. Now I know that. Now I know how to actually play the game and win more. That's wild. It's wild how that worked. There's another example. There was this really 1981 or something like that computer game called Wizardry, and what they tried to do, this was like, I think they were trying to do a computer version of Dungeons and Dragons because Dungeons and Dragons and coding, it's a lot of the same type of people do it. So now this game Wizardry, I never really played it, but I remember it. It was a big deal. Everybody thought it was this great thing, and it had all this incredibly detailed statistics underlying everything. I mean, no one could really figure out how it worked. That's how complex it was. You could kind of figure out basically roughly what was going on, but it would always surprise you. And there's people who would try to develop strategies playing this game, and they would lose. And then they would, okay, we'll try again, and they would lose again. And then no matter what they did, they couldn't figure it out. They just kept doing the things that weren't working. And in Wizardry back then, they didn't coddle the player. Like in that game, if you're what do they call them? Your characters, right? Your warriors and wizards and whatever. If they got killed in the game, they died, right? They didn't. There was no saving and restoring. Right? It was like that. So it was very difficult. So people kept trying, but they kept having problems with it. Well, somebody reverse engineered it, right? I'm not sure if they used AI or not, but they reverse engineered it. And by that, you go through the original code. If you don't have the actual code, right, the programmed code, you only have the executable, then you have to do all this stuff where you say, okay, well, every time this happens, let's trace it. Let's track the memory. Okay, we're going to track what happens and detect everything that changes. And then they do that, and they run it like 200 times or whatever. They run that little section 200 times of the game, and then they figure out, oh, I know what this is doing because we've run it 200 times, and it always produces some number between 1 and 6. So they know, oh, that's just a random dice roll. And so they figure that out, even though they don't have the code. Okay, and so they just do that for all of it, and they eventually come up with new code. Well, the new code is not, the codes themselves are not identical, but the output, the effect is identical. There is no difference between the two in effect, even though one is written and with different actual words and numbers than the other, but it's the same effect. Well, this guy who did that, it took him like 3 years. I guess he had plenty of time on his hands. But in the end, he found all these problems there. He found all these bugs in the code. He said he found something like 100 mistakes there, where it was like, well, this is obvious. Like in the manual, it says it's supposed to do this, but actually it only does this. And he said it's clearly because of this part of the code where, instead of saying, like it's like in a math equation where you put the parenthesis in the wrong place and it changes the outcome. He found a bunch of those. And he's like, it's obviously supposed to be this, even though it was that. So this guy goes in and corrects that mistake in his new code. Right? And he does that like with a bunch of stuff. At the end of that, he's like, "Hey, look, everybody, this is the fixed, perfect code there." And because he reverse engineered it, there were no legal ramifications on it. So he publishes this, and people start playing it, and they're like, "Oh my gosh, I remember this from 40 years ago or whatever. Wow, this one's so much better. It runs so much better now. Everything's better now on this game. It's a lot more fun. I win a lot more because there's not these bugs that are screwing everything up. There's not these code errors screwing everything up." And I just kept thinking, you could do this for things like games from 40 years ago for nostalgia purposes for a lot of people. And like, there's a big market for that. I discovered that while I was just playing around with this stuff. There's an enormous market for technology nostalgia. But I thought about it and I was like, man, you don't have to go back that far. What if you did this for things like 3 years ago? I mean, you could do 10 years ago. You could do 40 years ago. I'm not saying there's a problem with that. But why not do it for the whole time range? And like, we could just fix all the programming that wasn't going in the right ways. We could fix it all. I mean, and on top of that, I mean, here's the other thing. Like, the guy didn't do this, but I was like, well, maybe you could add new things, create more, what are they, like mazes for the game, new mazes, like improve the game, right? You could improve the code. I think there's a lot of potential there because so much code has been written that the world's infrastructure runs on. And what would it be like to go back and just optimize all of that? Right? Couldn't you like get, 10, 20, 30% better performance out of all this? I think in some cases you could probably double or triple performance. I think in a few cases you could probably 10, 20x the performance. Right? If there's a something that's particularly holding some implementation back, I think you could probably do that. So I expect a lot of that to happen in the coming days, weeks, months. I expect a lot of that to go on. I mean, think about like the energy grid, right? How much more efficient could the energy grid or use of electrical energy get by optimizing the software? I don't know. I'm not an electrical engineer, right? But my guess is there's some optimization that would increase the amount of energy available to everyone. I think there's probably some room for improvement there. There's probably more room for improvement in certain other things. I think certainly in, well, I don't want to get too into different areas, but I think things like education, there's probably a much bigger potential for upside there. So the whole point of what I'm saying here is that I think we're entering an age where we can go back and fix the broken code because we've got these intelligence agents, right? These intelligent agents now that they know how to do it, right? I mean, before you had to do it yourself with code. If you're trying to fix code, you had to do it yourself. But now you got these AI agents, you've got these intelligences that can do it, and quickly too. And I think we're going to do a lot of that. So I wouldn't be surprised if we start to see substantial efficiency improvements and maybe even major productivity jumps in various areas of things, because I think that's something that why wouldn't you do it, right? Why wouldn't you do it? Right, what's the downside? So look out for that over the next year or two. I really think there's going to be some pretty big efficiency gains in a lot of different areas because of that code and programming refresh and review. So that's a positive thing. That should make you feel good because you know that the potential is increasing. So thank you for being here with me today. If you found this interesting or useful, feel free to share it with others. Check out the program links in the description. If you like and subscribe, it helps my reach, but that's up to you. And yeah, tomorrow morning at 8:30, we're going to do simulation programming with the infinite love of the universe. It's always powerful. So join me for that, and I will